All right, welcome to review number 2. We are going to talk today about polynomial equations that have rational exponents. If you don't know what a rational exponent is, it's when you see a fraction. So right here, x to the 2/3 power, x to the 1/3 power, those are rational exponents. And so today we're going to talk about how do you solve equations that have rational exponents. Well, one of the methods you can use, and this is borrowed from calculus, is called U substitution. And so as I wrote, it's the technique of replacing a difficult variable with a more simple u. And if you're wondering, why is it the letter u? Well, it could be any letter you choose, but u doesn't get used very often, so we use that. Now, I'm going to just go ahead and give you an example of this. If this was something like this, x squared plus x minus 6 equals 0, if it didn't have those fraction exponents, I think almost anyone would be able to solve it just by factoring. So you would factor it like this. You just go ahead and say, well, I know the factors of this. It's x plus 3 and x minus 2. And you say x plus 3 equals 0, or x minus 2 equals 0, and you end up getting two solutions. Okay? Wouldn't it be nice if it was that easy? Well, I can tell you it is almost that easy, okay? But that's not what this problem is. We need to include the fraction. And so instead of it doing it this way, I'm going to go ahead and restart this. We're going to do this using a method called U substitution. And what this is we say, let a new variable u stand for one of these variables. And I do x to the 1/3 power. That's the same thing as this variable right here in the middle. We're just letting u represent that. And so where I see x to the 1/3 power, I'm going to write the variable u. What would x to the 2/3 power be? Well, that's just u squared, because it's twice as big. Then we can rewrite this equation as u squared plus u minus 6 equals 0. And as long as we know that u is x to the 1/3 power, this is still the same equation. It's just going to be solved in two parts. This is a lot simpler. So to solve this, I'm going to solve it with the same method. I'm going to solve it by factoring. And so I know the factors that multiply to be -6 that add up to be +1 are +3 and -2. And so in your head, you could probably tell me that u equals -3 or u equals 2. And really that's the right answer, but we don't want to know what u equals. We want to know what x equals. And so what you do then is once you get to that point where we have u by itself, then I'm going to take what x equals and I'm going to re-substitute it back in place where the u is. And so I'm going to write x to the 1/3 power equals -3, or x to the 1/3 power equals 2. And if you know this about rational exponents, when you see a fraction as an exponent, it's really like a square root or a cube root. It's a radical. But if you don't know that, if you didn't know that x to the 1/3 power is the cube root of x, you might think of a way to get rid of that exponent. Think of the reciprocal of 1/3. And so I'm thinking the reciprocal of 1/3 is 3. You could raise both sides to the 3rd power, like I'm showing you right here. And if you do that, it cancels out the exponent. You just get x. -3 to the 3rd power is -3 times -3 times -3. It's -27. Again, the same thing over here. X to the 1/3 power raised to the 3rd power cancels out. You just get x to the 1st power. And 2 to the 3rd power is 2 times 2 times 2, which is 8. Now you've solved the problem. Okay. And so that method is known as U substitution, and I'm going to show you how you can use it on problems that look a little difficult, but really once you get the first step done where you can replace a difficult variable with a u, it's really not that bad. So this was example number 1. We're going to do a total of 5. And again, it's a review. It's a technique you can use. If you don't want to use it, you don't have to. It's just one more tool you can have in your toolbox when you're solving equations. Let's go on to numbers 2 and 3. Again, we're doing a total of 5 today. So again, number 2, some of you could factor this without u substitution, but I'm going to go ahead and just use that same method in every problem. So the first thing you want to do is decide what variable are you going to let u equal. And I always let it to be the smallest exponent. Usually it's the middle term. And so for number 2, think about what would you let u equal? Would it be x to the 4th power or x squared? I'm going to say it's x squared. And so x to the fourth power is just twice as big as x squared. And so really, this could be u squared minus 50u plus 49 equals 0. Because if I took x squared and I squared it, I'd get x to the fourth power. So once we have it in this form, it becomes a really basic problem where you can solve it by factoring. And I'm not going to really review solving by factoring at this point. That should be easy for you. And so I'll just tell you that the factors will be u minus 49 and u minus 1, because negative 49 times negative 1 is positive 49, and negative 49 plus negative 1 is negative 50. And so then if I solve this by setting them both equal to 0, I can do this next step together. U equals positive 49 or u equals positive 1. And so it's just like an intermediate variable. We let u represent a variable that's difficult, and now we can go ahead and re-plug in x squared for u. Okay, so again, both of these are going to become x squared. And so it's x squared equals 49, or x squared equals 1. And now the next step, this might be a little bit difficult for some of you if you don't remember this, but the next step is to take the square root of both sides, okay, which I think makes sense. But I want to tell you that when you do a square root of a number, when you're solving an equation, remember that it's positive and negative. X equals plus or minus 7. Or here, x equals plus or minus 1. The positive square root, the square root of 49 equals 7, is the principal square root, but it's also true that the square root of 49 is also negative 7, because negative 7 times negative 7 is 49. And so there's actually two answers. You can write it like this. You can write it as x equals, and you can write it as like set notation. I'll kind of demonstrate this. X such that x equals, you give me some curly braces. You just list the numbers. It doesn't have to be in order, but it can be 7, negative 7, 1, and negative 1. And so that's the set notation answer of this. It's the same thing, just saying all the different answers that x could equal. Moving on to number 3, think about what would you let u equal. You have 2x, that looks pretty nice, but then you have 5x to the 1/2 power. That doesn't look very nice. But did you know that really x is equal to the same thing as x to the 2/2 power? Think of that. So if I were to do this, I would do it like this. I would let u equal x to the 1/2 power. And you know that x to the first power is twice as big of an exponent as x to the 1/2 power. And so for the same reason as before, this is u squared, because you take the 1/2 exponent, you double it, and you get just x. So then it becomes plus 5u minus 12 equals 0. It's a good rule of thumb. If you have it in descending order and it's a trinomial, this middle exponent is often what you're going to put as what u equals. So if you're stuck, you're confused, you don't know what to do, more often than not, it's the middle exponent. And so here we're going to solve this one by guessing and checking. You can use the quadratic formula if you'd like. And again, this lesson isn't exactly on how to solve by factoring. So I'm not going to really explain all those steps at the moment, but really we're trying to break apart 2u squared as 2u times u. And then for negative 12, we have to guess, is it 1 and 12, 2 and 6, or 3 and 4? And one's positive and one's negative. So the right answer is 2u minus 3 and u plus 4. If you were to try to check this, I'll go ahead and explain this part. You get negative 3u right here, and you get positive 8u, and if you add those together, you get 5u, which matches the middle. So I know that's the right factors, and so I can proceed from here. I'm going to erase this. Okay. And so really quick, we can solve this. I'll show all the steps. 2u minus 3 equals 0, or u plus 4 equals 0. And so here you get 2u equals 3, u equals 3 over 2. Here you get u equals minus 4. And so that's just adding or subtracting and dividing. Remember, that's not what we're looking for. Yes, we're finding what the answer is for u, but we want to find out what's this. What's the power of x? So we're going to go ahead and resubstitute what x equals. And so it's x to the 1/2 power equals 3 over 2, or x to the 1/2 power equals negative 4. And the final step is to go ahead and get rid of that exponent by doing the inverse. So if you see x, or the reciprocal, if you want to call it that. So the reciprocal of the exponent of 1/2 is a 2. We can raise both of these to the second power. Same thing on the right side. So it's just x all by itself, and then equals, you do 3 squared. 3 times 3 is 9, over 2 squared, which is 4, or negative 4 squared. Negative 4 times negative 4 is positive 16. And that's it. So you have two answers for x. Again, U substitution is a method you can use for these rational exponents. We're going to move on to our final two examples. Again, very similar to the first two. If you want, you can pause the video and try these yourself. I'm just going to go ahead and solve those for the people that are watching it. I'm going to let u equal the middle exponent, x squared. So 3x to the fourth power, if u is x squared, becomes 3u squared. Minus 5x squared becomes minus 5u, and then plus 1 equals 0. Again, we're going to solve this by factoring. The nice thing is that most of these problems can solve by factoring. And so, if I try to factor this, and I might have spoken too soon, I can't factor it. The only way I can make this positive one work, if I try negative 1 and negative 1 and I try this, I get negative 1u, I get negative 3u, negative 4u. There's no other ways to work. That doesn't equal 5u. So I was actually wrong. Not all the problems could be factored. That does, oops, I erased too much. That's all right. You don't have to give up and say, well, I guess I can't do it. There is another method to solve the quadratic equation. If you remember what that is, it's the quadratic formula. And so I'm not going to, explain what that is. I know you guys have actually used the quadratic formula before. And so that's a formula where the answer is normally x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that right there is their quadratic formula. We're not going to solve for x, we're going to solve for u first with it, but we're going to use the same thing. Remember that a equals 3, b equals negative 5, and c equals 1. Just the coefficients in front of the variables. So I'm going to go ahead and plug this in, but instead of being x, we're solving for u. So I'm writing u equals, the opposite of b would be 5 plus or minus the square root of b squared, which is 25, minus 4 times a times c, all over 2 times a. And if I simplify this a little bit, I get 5 plus or minus the square root. It's 25 minus 12, so 13 all over 6. Now that right there is actually okay for the answer. However, remember, we're not solving for u, we're solving for x. So this is what x squared equals instead of what u equals. X squared equals 5 plus or minus the square root of 13 all over 6. How do you solve this for x? Well, if it's x squared, you take the square root. But remember, it's plus and minus the square root. And so this is going to look really complicated, but it's x equals plus and minus the square root of the quantity 5 plus or minus the square root of 13 all over 6. Now I want you to ask yourself, how many answers does this actually have? Okay. If I ask you to make these into decimals, how many decimal answers would you get? I'm not going to do this at the moment, but you can go with the plus and a plus, that's one answer. You can do a plus and a minus, that's a second answer. And then the opposite, you can go a minus and a plus, that's one answer, and a minus and a minus, that's another answer. If you plug this in your calculator, you would get 4 different decimals. The nice thing is I'm going to let you leave it like this in exact form. It's complicated. This is a really difficult problem, but there it is. Just to make the video shorter, we're going to move on to number 5, but just know you could put this in and get actually 4 answers. Okay, and so that's a lot of answers. We'll find those later. Number 5, I'm going to let u equal this term, r to the 1/2 power. So r to the 3/2 power would be u cubed. R to the 1/2 power is u. This looks a little bit weird, but this is an easy problem to factor. You could factor out the variable u. So u factors out, you get u squared minus 1 is what's left over. Remember that this is a difference of perfect squares, so you should be able to factor that as u plus 1 and u minus 1. And so finally what you get is u equals 0, u equals negative 1, and u equals positive 1. And remember, that's not the final answer. The final answer is what you get when you resubstitute what u equals. So r to the 1/2 power gets plugged in for u's. R to the 1/2 power equals 0, r to the 1/2 power equals negative 1, and r to the 1/2 power equals 1. All right, and so when we finish this, again, we're just going to go ahead and use the reciprocal of the exponent. Some of you might know that this is a square root, and there's no square roots that give you a negative number, but we're going to go ahead and talk about this. It'll work out. If you square both sides, you're going to see that we're going to end up getting pretty much the same answer twice, and it'll all work out. So if I square this, I get r equals 0 squared, which is 0. This equals r equals negative 1 squared, which is 1. R equals positive 1 squared, which is 1. So these are the same answer, 1 and 1. There's actually two answers, r equals 0 or r equals 1. If you plug those into the original problem, 0 minus 0 ends up equaling 0, and 1 minus 1 also equals 1. So those are our two answers. They both work. Hopefully this has made a little bit of sense for you, and you now can use u substitution when you need to.